Alright, your sludge handling treatment disposal. Introduction to sludge handling and treatment disposal. Let's see if we can get in closer. Alright, introduction to sludge handling and treatment and disposal. Contents: 1. General consideration. 2. Sludge pumping. 3. Sludge thickening. 4. Sludge conditions. 5. Sludge dewatering. 6. Sludge digestion. 7. Sludge storage. 8. Bibliography. This course is adapted to Unified Facility Criteria, U.S. Government, which is public domain, authorized, unlimited distribution, not copyrighted. Alright, an introduction to sludge handling, treatment, and disposal. General consideration: sludge residual fuels, end of product, wastewater treatment, whether biological, physical, chemical treatment. Primary sludge is about 3 to 6% solids. Treatment objectives are reduction of sludge volume, rendering it suitable for the ultimate disposal. Secondary objectives are to utilize generated gas and an anaerobic digestion selected as part of the sludge management strategy. In addition, attempts should be made to utilize the sludge as a soil conditioner rather than paying to dispose of it. 2. Sludge pumping. Sludges less than 10% solids can be pumped through force mains. Sludge solids contents less than 2% have hydraulic characteristics similar to water. For solids contents greater than 2%, however, the friction loss is 1/2 to 4 times the friction loss of water. For water, both head losses and friction loss increase with decreasing temperature. Velocities must be kept above 2 feet per second. Grease content can cause serious clogging. Grit will adversely affect the flow characteristics as well. Adequate cleanouts and long sweeping turns will be used when designing facilities of these types. 2.1 Piping. Sludge withdrawal piping will not be less than 6 inches diameter. Minimum diameters of pump discharge lines are 4 inches for the plantless, or 0.5 million gallons per day. 8 inches for plants larger than 1.0 million gallons per day. Short straight pipe runs are preferred. Sharp bends or high points are to be avoided. Blank flanges valves should be provided with flushing purposes. 2.2 Pump. Sludge pumps will either be plunger, progressive cavity, torque flow, or open propeller. Central figure types. Plungers, progress, and cavity pumps generally should be used for primary sludges. Central figure pumps are more suitable for lighter secondary sludges. Central figure and torque flow pumps are used for transporting digested sludge. In most cases, plunger, progressive cavity pumps are used when suction lift is involved. Plunger pumps are as well as suited for sludge eluteration. Sand pipes are required for primary and secondary sludge pumps, as well as sludge eluteration pumps. The pump information provided with the guidance only does not represent design criteria. Alright, 2.2.1 The plunger. Advantage of plunger pumps may be listed above. Pulsating action intends to deconcentrate the sludge in hoppers as ahead of the pumps. There's suitable suction lift up to 10 feet or self-priming. Low pumping rates can be used with large pore openings. Positive delivery is provided unless some of the object prevents ball check valves from seating. They have constant and adjustable capacity regardless of the large variations in pumping head. Large discharge heads may be provided for. Head solid concentrations may be pumped in if the equipment is designed for load conditions. Plunger pumps can come from simple, complex, triplex modules, capacity of 40 to 60 gallons per minute per plunger. Large models are available. Pump speeds will be between 40 to 50 revolutions per minute. Pumps will design for a minimum head of 80 feet, since the grease accumulations in sludge lines can cause progressive increase to head within the use. Capacity is decreased by shortening the stroke of the plunger. However, the pumps would seem to operate more satisfactory at or near full stroke. For this reason, many pumps provided with a variable pitch V-bell drives for speed control capacity. 2.2.2 Progressive cavity. The progressive cavity pump can be used successfully, particularly on concentrated sludge. The pump is composed of a single-threaded rotor, operates minimum clearance with a double-threaded helix. rubber and self-priming suction at least lifts up to 28 feet, available with a capacity of 350 gallons per minute. We will pass solids up to 1 and 1.25 inches in diameter. Centrifugal pumps. With a centrifugal pump, the objective is to obtain large enough pump to pass solids without clogging, but small enough capacity to avoid pumping a sludge diluted with large quantities of overlying sewage. Centrifugal pumps of special design can be used for pumping primary sludge in large plants greater than 2 million gallons per day. Since capacity with centrifugal pumps varies with the head, which can be usually specified greater enough so that pump may assist dewatering the tanks. The pump's considerable excess capacity under normal conditions. Throttling discharge to reduce the capacity is impractical because of the frequent stoppage here. Hence, it is absolutely essential that the pumps be equipped with variable speed drive. Centrifugal pumps of the bladeless impeller type have been used for some extent. In some cases, they have been deemed preferable to either plunger or screw-fed type pumps. Bladeless pumps have approximately one-half the capacity of the conventional non-clog pumps, the same nominal size. Consequently, the approach hydraulic requirements more closely. The design of the pump makes clogging at the suction impeller almost impossible. 224, your torque flow. This type of the pump uses a fully recessed impeller, is very effective at conveying sludge. The size of the particles can be handled, limited only by the diameter of suction discharge valve. Rotating impellers develop a vortex of the sludge. Main propulsive force is the liquid itself. 225, pump application. To the types of sludge pumps, including primary chemical, trickle filtering, activated, aerated, thickened, concentrated, and scum that accumulates the various points of treatment, it must be also pumped. Alright, 226, primary sludge. Ordinary desirable to obtain concentrated sludge as practical for the primary tanks. Characteristics of the primary raw sludge will vary considerably depending on the characteristics of the solid waste bar and the types of the units, their efficiency, while biological treatment follows quality solids adds the following: overflow liquors for digestion tanks, wasted activated sludge, human sludge, the settling tanks following the trickling filters, and overflow liquors from sludging aeration tanks. Character of primary sludge is such conventional for non-clog pumps will not be used. Plunger pumps may be used with the primary sludge. Centrifugal pumps, screw feed, bladeless type, torque flow pumps may also be used. 227, chemical precipitation sludge. Sludge with chemical precipitation process can usually handle in some manner as primary sludge. 228, trickling filter, activated sludge. Sludge with the trickling filter is usually some homogeneous character, but they can be easily pumped with either the plunger or non-clogging centrifugal pump. For an activated sludge, dilute contains only the fine solids so that it may be pumped readily with a non-clogged centrifugal pump, but which must operate with a slow speed to help prevent with the fluorescent character of the sludge being broken up. Aerated, thickened, and concentrated sludge. Plunger pumps may be used with the concentration sludge accommodated with the high friction head losses in pump discharge line. The progressive cavity type of the positive displacement also may be used. The dense sludge contains up to 20% of solids, so because these pumps have limited clearance, it's necessary to reduce all solids to a small size. 2210, scum pumping. Screw feed pumps, plunger pumps, pneumatic ejectors may be used for the pumping scum. Bladeless torque flow centrifugal pumps may also be used for this service. 2.3, control. The pumping of the sludge often requires operation less than the required design capacity of the pump. For the small treatment plan, the designer engineer will evaluate user of the timer to allow the operator to program pump for on and off operation. For large treatment plants, use of variable speed control should be investigated. Alright, 3, sludge thickening. Thickening is provided with a reduced volume sludge. Two basic thickness types of thickeners, but work with the gravity and flotation. By gravity or flotation, either the continuous or batch process. Gravity thickeners are essential for the settling tanks with or without mechanical thickening device. Picket fence type. Plain settling tanks can be produced solid contents of sludge up to 8% for primary sludges and 2.2% for activated sludges. Activated sludge can also be concentrated resettling in the primary settling tank. 3.1, gravity thickeners. A gravity thickener will be designed on the basis of the hydraulic surface loading and solid loading. The design principles are the same as those of the sediment tanks. Bulky sludges of high sludge volume index require low loading rates. Use a chemical acid lime and the polyelectrolytes also higher loading rates, minimum detention time, and sludge volume divided in sludge removed per day, which represents the time a sludge is held with sludge blanket. And the sludge blanket is usually less than 2 days. Table 1 gives the mass loading to be used for the design gravity thickeners. 3.2 Flotation thickening. Flotation thickening causes solid sludges to rise surface when they are collected, accomplished by using dissolved air flotation process. The process is best suited with activated sludge treatment with solid contents of 4% with higher obtained. Table 2 provides design values of flotation thickening. Table 1 mass loadings design thickeners. Primary sludge 22 pounds square foot a day. Primary thickener filter sludge 15 pounds per square foot day. Primary waste activated sludge 6 to 10 pounds per square foot a day. Waste activated sludge 4 to 8 pounds per day. Table 2 parameters in typical view. Air pressure PSI gauge 40 to 70. Effluent ratio of the percentage of the influent flow 30 to 150. Detention time hours 3. Air to solid ratio pound to pound solid 0.02. Solids loading pounds per square foot day 10 to 50. Polymer addition pound to TOM. Dry solids 10. Alright, 4. Sludge conditioning. Chemical condition. Chemicals activated may be used with improved sludge dewaterability by acting as coagents. Chemicals commonly used as ferric chloride, lime, and organic polymers. Application of the chemical condition vary dependent on the sludge characteristics of the operating parameters. Therefore, a treatable study will be used to determine specific design factors such as chemical dosage. Nevertheless, Table 3 provides a range of dosages which are typically various sludge types. Table 3 is the dosage, chemicals, various types of sludges, condition, percentage, and dry solid sludge solids. Description: fresh solids digested. You have iron, chlorine, calcium, and we got ferric chloride and lime. Primary 1 to 2, 6 to 8, 1 point digested, 1.5 to 3.5, 6 to 10. Primary trickling fission fresh solids 2.3 to 6.8, 1.5 to 3.5, 6 to 10. Primary activated 1.5, 2.5, 7 to 9, 1.5 to 4, 6 to 12. Activated alone fresh solid ferric chloride 4 to 6. Alright, 4.2 physical condition. Physical condition, primary heat condition involved with about 350 to 390 degrees Fahrenheit for 3 minutes over the 180 to 210 pounds per square inch. Dewaterable is improved dramatically. Pathogens are destroyed as well. The main disadvantage is the return of high biochemical oxygen demand loading in the wastewater treatment system. Solids dewatering. Dewatering reduces the moisture content of the solids of the sludge so they can more easily be disposed by a landfill, incinerator, heat drying, composition, other means. Objective of the moisture content 60 to 80% depending on the disposal method. The EPA Manual 625182014 provides information capability of various dewatering device methodology of selecting cost-effective devices. Because all watering devices depending upon the proper sludge conditioning and careful design, chemical feed system should be included with the 12 of the dewatering facility. Belt pressing, filterization. Belt filter presser employs single to double the moving belts for the continuously dewatering sludge through one or more storage dewatering. All the belt presses filterization process include 3 basic operational stages: chemical addition of feed sludge, gravity drainage, non-fluid consistency, shear and compression. Dewatering drainage sludge. When dewatering 50-50 mixture, anaerobicals design primary waste activated sludge belt filter press will typically produce case solids concentration at 18 to 23% range. Alright, 5.1.1 physical description. Figure 1 depicts a simple belt process show the location of 3 stages. Although present-day processes usually are more complex than follow simple principles indicated in Figure 1. Dewatering process made effective with the 2 endless belt synthetic diver belt passes around the system rollers, constant speed, performing function, conveying, draining, and compressing. Main belt presses all use of the initial belt over the gravity drainage additional with the 2 belts pressure zone. 5.1.2 process description. Good chemical condition is very important. The successful consistent performance of the belt filter process fluctuate usually as an organic polymer is added to the sludge prior to being fed into the belt press. Be free with the water drains from the continuation sludge gravity drain stage of the press. The sludge enters the 2 belt contact zone where the Second, upper belt is gently set on the forming sludge cake. The belts and the captured cake between them pass through the rollers, generally decreasing the diameter of the stages subject with the sludge, continuously increasing pressure, shear forces. Pressure can widely be designed within the sludge presses, moving the low pressure section to medium pressure section. Some pressures include high pressure section provides additional dewatering, progressive more and more water expelled throughout the roller section, and when the cake is discharged, the scaper blade is often employed with each belt at the discharge point to remove the cake from the belt. Two spray wash belt cleaning stations generally provided to keep the belts clean. Typically, secondary effluent can be used in water source spray wash. High pressure jets can be used in equipment and self-cleaning devices continuously remove any solids which may tend to plug the spray nozzles. Alright, 513, performance variables. Belt press performance is measured by the percent solid sludge cake, percent solids captured from the solids and hydraulics. Loading rates are required polymer dosages. Several machine variables includes belt speed, belt tension, belt type, influence belt type performance. Alright, 3 basic stages of the belt filter. Stage 1, chemical condition mixer, inline injection sludge and polymer solution. Then it goes through the stage 2, gravity designer conditional sludge, wash spray. And then stage 3 is your compression, dewatering, wash spray, filtrated, wash water, dewatered sludge, wash spray. 514, advantage and disadvantage. Table 4 lists a table of advantage for the disadvantage belt filter the breast compared with the dewatering process. 515, design shortcomings. Commonly design shortcomings associated with the belt filter installation. Their solutions are listed in Table 5. Sludge drying beds. Sludge drying beds rely on draining and evaporation effective with moisture reduction. These beds are open and as such with a very selectable climate condition, precipitating sunshine, air temperature, relative humidity, wind velocity. For example, sludge drying 6 weeks in the summer would take at least 12 weeks in the winter. Sludge bed drying efficiency can be improved significantly to cover the bed of glass or plastic by providing artificial heat. Heat could be applied by using waste biogas as fuel. Waste heat over the waste-based power plant. Figure 2 illustrates the typical bed. Alright, Table 4 shows the advantage of belt filter and presses. Table 5, common design shortcomings, belt filter press installation shortcomings, resilience problems and solutions. 521, designer factors. Our requirements can be interpreted in terms of per capita values. Table 6, the variables vary arbitrarily, depend largely on the climate conditions. Embankment heights will be 12 to 14 inches using concrete block walls. Under drains are to provide with lateral ties of 12 feet apart. Their transport of lashette must be returned to the head of the treatment plant. 8 to 18 inches bed of gravel ranging size of 0.1 to 1 inch is placed on the under drains. The sand placed on the gravel of a depth of 18 inches with the sand being washed and dirt free. Sand effective slate size will be 0.3 to 0.75 millimeters width. Uniformly conformant to no more than 4.0. Sludge distribution can be various design, although impervious splash plate in some kinds is always provided. Sludge cake removal can be by hand or mechanical means. Bed widths may range from 15 to 25 foot, with lengths of 50 to 100 feet, and the polymer is added condition in the bed. Alright, this shows your planned sectional type sludge and dry bedding. 6 fine 3 coarse spread, 3 in fine gravel, 3 in medium gravel, 6 to 6 in coarse spread. Shows medium gravel, coarse sand, 6 inches undergrain. Your 6-inch shear gate, splash boxes. Our length can be reduced to 50 to 75 feet to prevent poor sludge distribution over the bed. Bolt-type beds provide operational flexibility which will be used appropriate enclosed beds with sides no higher than 18 inches, although that is not to shave the sludge. Open side forced ventilation and artificial heating are possible modifications. Usually on the combination open-closed bed performs best in an average situation. Odor and insects can be problems unless the sludge is digested completely. Land requirements and sludge cake removal costs are some of the disadvantages. Table 6 shows the area required for tight sludge drying beds, square foot per capita. Primary digested 1.5 to 1. Primary human digest 1.75 to 1.25. Primary activated digest 2.5 to 1.5. Primary chemical precipitated digest 2.5 to 1.5. Alright, 5.3, vacuum filterization. Vacuum filterization reduces sludge moisture content, applying vacuums to 10 to 10 to 25 inches of mercury through sludge layer using various equipment configuration. Vacuum filters can be drum type, belt type, static discharge type, coil type, using collagen pretreatment necessary for the good dewatering efficiency. Your ferric chloride, collagen aid, merrick, commonly used, generally higher than feed solid concentration. Higher the filterization rate, filter yield for each solids, however, will be limited to 8 to 10%. Prevent difficulties handling the sludge. Figures 3 show the typical vacuum filter applications. Alright, rotary vacuum filter. Let's try to zoom in on this actually. I can't read it, but you can see the picture. The sludge inlet, sludge pit, sludge pump, activator condition tank, agitator V, and enter drum, metering pipe, filter drum, vat, washing return, drying. Alright, 5.3.1 filter yields. Filter yields vary from 2 to 15 pounds per square foot per hour. Various types of sludge. Vacuum filter with digested activated sludge will design yield 2 pounds per square foot per hour. The vacuum filters raw primary sludge will design for the filter yield of 10 pounds per square foot per hour. The design filter will be peak sludge removal required with about 15% area allowance. Maintenance downtime will be assumed that the filter units will be operated for 30 hours per week. 5.3.2 filter size. Equipment filter size with cover the wide range can be fit 12 inches in diameter, fitting filtering up to 600 square feet. Vacuum filterization units are normally supplied with essential auxiliary equipment of various manufacturers. Disposal of the filter rate. The watering liquids will be returned to the head of the treatment plant. For the reason solid concentration, vacuum filter must be kept as low as practical. It can be assumed to be 10%. Centrifugation. The centrifugal dewatering of the sludge process will use the water developed by fast rotation cylindrical drum or bowl to separate the sludge solids from the liquid. In basic process, sludge slurry is introduced with the centrifuge of the force against the bowl's interior walls, forming a pool of liquid density with the difference caused by the sludge solids and liquid separated into 2 distinct layers: sludge solids cake and liquid concentrate. These separately discharged from the unit. 2 types of centrifuges use municipal sludge dewatering basket, solid bowl, both operating from the basic principle of the different type of the method. Sludge feed magnitude applied centrifugal force. Method solids liquid discharge cost performance. Basket centrifuge. The imperforated basket centrifuge is a semi-continuous feeding solid discharge unit that rotates on a vertical axis. Schematic of the diagram: basket centrifuge, sludge feed, and sludge plowing cycles is shown in Figure 4. Sludge is fed from the bottom of the basket. Sludge solids within the cake of the bowl walls. As the unit rotates, the liquid concentrates and is displaced over the baffle and weir of the top of the unit. Sludge feeds either continued for a present time until the suspended solids of the concentrate reach the present concentration ability to be either thickening, dewatering advantage of the basket centrifuge. Basket centrifuge with a typical dewatering 50-50 blend with an anaerobical digest primary wasted activated sludge 10 to 15% solids. Alright, 5.4.1.1 process description. After sludge feeding is stopped, the centrifuge begins to decelerate and special skimmer nozzle moves into the position. Skimmer relatively soft, low solids concentrate sludge in their peripheral of the sludge mass. These skimmings are typically returned by the plant head works of the digested. After skimming operation, centrifugal show further about 70 revolutions per minute. A plowing knife moves into the position to cut the sludge away from the walls. Sludge cake and the drops open the bottom of the basket. After plowing terminates, centrifugal begins to accelerate. Feed sludge is again introduced. At no time does the centrifugal actually stop rotating. And it shows the liquid sludge in and basket sludge feed, and centrifugal out, plowing knife retracted, plowing knife extended, and sludge plowing dewatering saws out. And figure 5.4.1.2. Application: the cake solid concentration produced with the basket machine, typically not as dry as that achieved with a solid bowl center figure. However, the basket with the central figure is essentially suitable for the dewatering biological fine solids and sludges that are difficult to do. Dewatering sludges where nature of the solid varies widely, and for sludges containing significant grit, the basket centrifuge must be commonly used with the thickening waste activity sludge. A basket centrifuge can be a good application in and small plants capacity ranging from 1 to 2 million gallons per day, where thickening is required before and after stabilization. Dewatering 10 to 12% of the solids is adequate. Basic centrifuge is sometimes used in larger plant. 5413 advantage, disadvantage of the imperforate basket centrifuge compared dewatering process presented in Table 7. Table 7, the disadvantage basket centrifuges, advantages and disadvantages. 5414, design shortcomings. Common design shortings is experienced in basket centrifuge listed and their solution presented in Table 8. Table 8, common design shortings, basket figure installation, shortcoming, resilient problem solutions. 542, solid bowl central figure. Solid bowl central figure technology has greatly advanced for the recent year of the bowl conveyor life, and the machine performance has been improved with many treatment plants. The U.S. older solid bowl central figure installation have required high maintenance expense due to the rapid wear of the conveyor and required due performance. Recently, use of the replaceable ceramic tile of the low G centrifuge, less than 101 Gs, cinder tungsten carbide tile with a high G sensor greater than 100 Gs have greatly increased operating life prior to the overhaul. In addition, several of the centrifuge manufacturers also offer stainless steel construction contrast to the carbon steel construction claim. Uses material result less wear of the vibration caused by corrosion. Revised bowl configuration to use the new automatic backdrive with eddy current brakes that has resulted in improved reliability. Process control result in improvement in dewatering performance. Also, in recent years, central figure manufacturers have reduced recommended throughout their machines direct response completion of the bell filter press that has allowed for the increase in solid residence time and central figure subsequent improvement in cake dryness. 5421 physical description. As a potatoes must simultaneously feed discharge cycle of the imperforated basket drainage for the solid bench bowl central figure, also called decelerator scroll centrifuge. The continuous operation unit of the centrifuge shown in Figure 5 with the existing rotating horizontal cylindrical bowl containing screw type of the conveyor with the scroll that rotates but all slightly lower high speed than the bowl. The differential speed difference of the revolution per minute between the bowl and the conveyor with the conveying of the solid required with the screw conveyor can rotate with a different speed with the bowl. Rotating bowl or shell support with between two shell bearings at one end of the neck down to the cylindrical slow section that acts as a dewatering breech drainage deck, and for the screw type conveyor sludge into the rotating bowl with the transition feed pipe extended with the hollow shaft of the rotating conveyor and distributed through the ports and the hollow shaft of the pool within the rotating bowl. Figure 5 shows a constant and continuous concurrent solid bowl central figure. A differential speed century discharge port adjusted, central discharge, sludge cake discharge, rotating conveyor, rotating bowl, cover, dewatering beach, main drive sheath, bearing condition, base not shown, feed, and sludge chemicals. Alright, 5422 counter concurrent central figure. Centrifuge illustrated in Figure 16.5 operates with the current and mode of the influence sludges have with the feed pipe under centrifuge force. For sludge solids that settle through the liquid ball wall because of their density greater than that of the liquid solids, then move gradually by rotating conveyor with the left over the right across the bowl with the dewatering beach of the outlet ports there drop the downward with sludge cake through the discharge hopper and settle sludge move over the left to the right through the bowl toward the sludge cake outlet. Progressively finer solid settle centrifugally rotating bowl wall. The water concentration drain with the solid with the dewatering beach of the back end of the pool. The center to actually move at the end of the feed pipe. Left discharge from the bowl from the ports. Left end when the opposite end of the centrifuge dewatering beach. Location central removal points adjusted for the location. Established design with the pool in the bowl. 5423. Concurrent centrifuge. Second variation solid bowl with the centrifuge concurrent model shown in Figure 6 is unit. This liquid sludge introduced in far end of the bowl with the dewatering beach solid sludge solids liquid follow the same direction. General construction is a similar countercurrent design, except for the concentrate does not flow with a different direction in the sludge solid. Instead of the concentrate withdrawal and skimming the device, return to the tube located near the junction of the bowl and the beach. Clarified century that flows with the channels inside the scroll hub, the return to the feed end of the machine where it is discharged or over adjustable wear plates through discharge port built in the bowl head. Continuous concurrent solid bowl, central figure, feed pipe, sludge conditioner, concentrate discharge, rotating bowl, rotating conveyor, and scroll cover, concentrate withdrawal, dewatering beach, sludge cake discharge, gear reducer back drive. 5421 differential speed relative to the new development solid bowl decanter centrifuge is used with the back drive with the control of speed differential between the scroll and the bowl. Objective of the back drive with the control of the differential to give the optimum solids residence time of the centrifuge thereby producing the optimum cake solid content. Back drive some type is considered essential with the dewatering secondary sludge because of the fine particle present. Back drive function can be accomplished with a hydraulic pump system, eddy current brake by direct current variable speed motor, Reeves type variable speed motor. The two most common back drive system, hydraulic back drive, eddy current brake. Alright, 5425 insulation. Many centrifugal installations have century mounted feet above the floor using bell conveyor to be moved dewater, cake water, otherwise method of installing solid bell central fuel to put in the central fuel on second floor 2-story building, dropping the dewater cake into either trucks or storage hopper on the first level of the mounting centrifuge about a foot off the floor to drop the cake, and then screw the conveyor built into the floor to let the central fuel cake drop into an open throated with a progressive cavity type pump from the transfer of the cake to truck to incinerator storage. Alright, 5426, advantages, disadvantages. Some of the advantages, disadvantages of solid bowl decanter centrifuge compared with the other dewatering processes are presented in Table 9. The ability to be used thickening dewatering provides flexibility. Majority advantage of the solid bowl centrifugal, for example, centrifuge can be used for thickening, adding filter presses, reducing chemical uses, increasing solid throughput during periods of downtime. Filter press solid bowl centrifuge can serve as an alternate dewatering device, and an advantage of the solid bowl centrifuge. Larger plants are available to equipment, larger sludge throughout the capacity of the single units with any type of the dewatering equipment. For larger centrifuges are capable of handling 30 to 300 to 700 gallons per minute per unit. Depending on the sludge characteristics, the centrifugal also has the ability to handle the higher design loading, temporary increase of the hydraulic loading or solid concentration, and percent solid recovery can be easily maintained within. The addition of moly polymer, the cake solid concentration drops slightly. Centrifuge will stay online. Solid bowl centrifuge typically capable of the dewatering 50-50 mixture and aerobotically digest primary and secondary sludges 15 to 21% solid concentrate. Table 10 lists common design shortcomings in their solution. Table 9 advantage disadvantages of solid bowl decanter centrifuge. Table 10 common design shortcomings solid bowl decanter central fuel installations. Alright, 5.5 filter press. The plate and frame press, this batch device has been used to process difficulty with water sludges. Recent improvement of the degree of the automation filter media unit capabilities have led to renewed interest in pressure filterization for applicant and municipal type sludges. The ability to produce very dry cake and clear filtrate major components in favor of pressure filterization may have higher capital operating costs than vacuum filters. Therefore, in presence of vacuum filters will be accepted provided they can be economically justified. Figure 7 illustrates the cross-section filter press. Shows the cakes in this volume, the filtrated cloth, the sludge feed, the filtrated cloth, the rigid plate assembly which holds the filter cloth, and the filtrated. Alright, Control over the filter process of the manual, semi-automatic, or full automatic labor requirements operation vary dramatically depending on the degree of the installation utilized. Control display automation operation attention often needed during the dump cycle. Ensure complete separation solids for the media and filter process. Process shields typically increase to 10 to 30% of the carefully controlled of the optimum cycle of the micropressor. This is important since the capital costs of the filters are very high. 552. Advantage and disadvantage. Table 11 presents the principal advantage and disadvantage of filter press compared with the other dewatering process. Commonly designed shortcomings associated with filter press installations are listed in Table 12, along with solutions of the shortcoming, fixed volumes, increased cess. Plate filter press typically dewater 50-50 blend digested primary activated sludge to be joined 35 to 42%. Solid diaphragm press will produce 38 to 47% solid cake on the flame sludge. The cake solids concentration include large amount of inorganic conditioning chemicals. Table 11 shows disadvantages and advantages of filter press. Table 12 shows the shortcoming design shorting of the filter press. Alright, 6. Your sludge digestion. Aerobatic sludge digestion. Major function of sludge digestion is the principal advantage stabilization sludge in terms of vital content of the biological activity. Aerobatic digestion accomplishes through biological oxidation cell matter, which is done without the production of volatile solids and high biochemical oxygen demand liquor associated with the anaerobic digestion. 611 modes of operation. Anaerobic digestion with either be continuous intermittent batch operation, waste sludge feed will be discontinued, specify the time before digested sludge will withdraw. Continuous operation supernaut is constant withdrawal. The mode of the operation used when the phosphorus is a problem. Low phosphorus levels are required for influential fluent because of the batch operation produce higher phosphorus concentration in supernaut. 612 design factors. Some of the design factors given in Table 13 tank with the is open, which can be probable to cold climates with the mechanical aeration. No heating of the required. Some of the increased volatile solid reduction can be obtained with increased temperature. Tank design still Miller's aeration design and the addition sludge thickening at prudency. Major advantage in aerobatic digestion is high energy requirement. 6.2 anaerobatic sludge digestion. Your process description. Anaerobic sludge description is the destruction of biological solids used within bacteria function, absence of oxygen, process for the produce of the methane gas, which can be used with the energy source can make anaerobic digestion more economically attractive to the aerobatic digestion. Larger than treatment plan, the greater the economic incentive of the aerobatic digestion. Anaerobic digestion is considered more difficult to operate with the aerobatic digestion. Methane producers could be great benefit with the cold regions as supplemental source of heat. Appendix D represents detailed information concerning the installation reactors, piping, and cold climate. Therefore, the decision to use anaerobic digestion must be carefully evaluate the operational capabilities of the installation. Objective. The objective of the anaerobic digestion stabilization, organic solid sludge volume reduction, order reduction, destruction of pathogenic organisms, useful gas production, improvement of sludge dewaterability, volatile solids type of the produced 60 to 75% from final volatile matter contents 40 to 50%. Table 13 shows your anaerobic digestion design parameters. Alright, 623, conventional standard rate of digestion system. This type of the system consists of a single two-stage process where the tanks provide with the digestion, supernaut separation concentration under the following loading. Two-stage process for the more applicable plants having the capabilities more than 1 million gallons per day. Retention period is in the first tank, stage tank will be 8 days to 22 days in second storage tank. Minimum total retention time will be 30 days if the tank is heated with 95 degree Fahrenheit. Unit capacity required for the separate unheated tanks will be increased in accordance with local climatic conditions, but not less than twice the value indicated with each of the three sludge sources in Table 14. Table 14, standard rate anaerobic digester capacity design criteria. Feed sludge source, primary settling 3 cubic feet capita, trickling filter, primary setting 5 feet cubic feet capita, activated sludge, primary setting 5 feet cubic feet capita. Our Table 15, higher rate anaerobic digester capacity design criteria, primary setting only 2 feet cubic feet, trickling filter, primary setting 4 cubic feet, activated sludge, primary setting 4 feet. Alright, 6.2, high rate digesting process is first standard rate process. The solid loading rate is more greater than up to 4 times, but the retention period is lower than 1/2. Mixing capacity greater or improved. The sludge is always heated. Higher rate tanks will be those with the digestion process accomplished separately with the supertransit Separation sludge concentration storage includes rapid and intimate mixing raw digested sludge into the entire tank contents operating at temperature of 95 degrees Fahrenheit. Process will be two-stage system applicable to treatment plants capacity greater than 1 million gallons per day. Primary digesting tank considered the high rate tank. If sludge dry beds bonds are to be used with dewatering digested sludge retention time. Solid and primary digester will be 15 days per mechanically sludge dewatering process are employed. Retention time in the primary digester may be reduced to 10 days. Secondary digester must also be sufficient capacity to provide separation storage of digested sludge. Primary digestion will be sized up to 75% of the total design tank volume. Alright, 625, pH control. pH level of the sludge inside of the digester critical factor anaerobic digestion will be kept at as near to 7 as possible. The range of 6.6 to 7.4 is considered acceptable. Also, monitoring volatile acids to alkalinity ratio is important. pH and maintain bicarbonate buffering. When natural buffering fails, pH becomes less than 6.6. Hydrated time calcium hydroxide should be added to the digester. Design provisions may provide a simple means with adding liner of the digester if needed. One of the more practical means with the provided convention, a manual addition to the lime, the raw sludge prime pit before raw sludge is pumped into the digester. Alright, 6.3 tank element design. Tank dimension, no particular shape poses advantages over all the other, but circular tanks are more popular. Circular tanks will not be less than 20 feet or more than 100 feet in diameter. Sidewall water depth of minimum 20 feet to a maximum of 30 feet. 2.5 feet freeboard will provide between the top of the wall with the working liquid level. The mechanism of the removing the sludge. The bottoms of the tank will be flat. Otherwise, hopper bottoms with a step slow. Within 3 feet horizontal and 1 foot vertical will be provided. All tanks designed treatment plants rated with above the 1 million gallons per multiple units. 632, two types of covers that are used: sludge digestion, fixed and floating. Combination cover. The fixings will be used primary stage, 2 stage digestion process. Floating covers will be used in the secondary stage. Glue floating is the covers separate discharge, gesture cold region, freezing, ice, snow, and air problems. Fixed covers may use to provide gas collection domes installed at the top of the cover. At least 2 access manholes provided in the tank roofs. In addition, the tank covers are provided with a sampling, well pressure, and vacuum relief valve with the flame traps. Alright, 633, control chamber. The entry for the control chamber must be designed with safety operated equipment. The form of the chamber will be white and well ventilated, equipped with water for the drain with sludge heating equipment. The pass pipe and gas main for the control of the prudency located in separate structure above mentioned structures will be explosion-proof construction. 634, piping. Particular piping requirements. The sludge digester will include provision of additional sludging, withdrawing sludge, multi-level supertenant, removal points, heating, recirculating sludge supertenant, flushing sample, gas collection, gas recirculating supertenant. The required return it into process further treatment. The supertenant draw-off facilities will be designed to provide variable rate of the return to prevent plan upset. 6.3 heating. The method to use the heating sludge digestion is the circulation contents of the tank being from the heat exchanger. Heated tanks will be insulated heating equipment sized to maintain temperature of 95 degrees Fahrenheit during the coldest weather conditions. 636, chemical feeding. Particular means the feeding lime and the other chemical are commonly used with the correct digester operating. Problems must include part of the digester design. 63, gas collection. Sludge gas, it will be collected with the digester either by utilizing or for burning it to waste. 2-stage units will provide interconnecting lines permit and transfer storage from one unit to the other. Gas withdrawal will be from a common point. 6.3 gas utilization. Gas storage facilities will have provided with the gas to be utilized not withstand burning sludge gas. A heat value between 500 to 700 British thermal units per cubic foot. Average gas yield 15 cubic feet per pound of the volatile solid destroyed. Alright, 7, your sludge storage. Sludge tanks. Sludge storage tanks may have the depths not less than 15 feet. Bottoms less than 1 in forward. The tanks may be open and closed. Ventilation must provide with a closed tank. Decanting lines as well as sludge withdrawing line must be provided for all tanks. 672 sludge retention ponds. Sludge retention facilities will provide either the treatment plan with the land application for the design. The intention period will large enough to compensate for the play periods where when sludge spreading is not feasible will not be less than 30 days. Sludge will permit operational flexibility, additional destruction, pathogens, other further sludge stabilization. 7.3 Sludge storage ponds. Sludge storage ponds are applicable storage. Well digested sludge land is available for storage. Usually, the 2 to 3 years, moisture content is reduced 50 to 60%. Lagoon storage can be used continuous operation confined peak load situation. Serve the simple economical sludge storage techniques. Land requirements possible. Groundwater pollution major advantages. And you got ultra AGU bibliography. And it's probably the lengthy bibliography, like, yeah, it's pretty lengthy bibliography. And then it goes into the final exam, and this was a reading of the Introduction Sludge Handling and Treatment Disposal.